All right, this is example C for quadratic equations in vertex form. This is the last part of the lesson. Example C says, given the vertex form, convert to standard form. So we already did in example A, we were given the standard form, that was the ax squared plus bx plus c, and I wanted to convert it to the vertex form, where it looked like ax minus h squared plus k. So now we're going reverse. All right, and this can be pretty simple to do if you remember the perfect square trinomial. So, because all of these have a square, right? And if it's squared, it means that we're supposed to write it twice. So technically this would be like 2, I would have x minus 3, and another x minus 3 because of the square there, and then I would take away 5. So I would have to FOIL this, right? And then I would have to multiply all of that by 2, and then I would have to take away the 5. So there is a shorter method if you can remember the pattern. Okay, it's just going to be your a squared minus 2ab plus b squared, or in this case, the x's. Let's go to the cloud. Let's talk about this. If I had given you an x plus 5 squared, right? It's going to be the first thing squared, which is x, so x squared plus 2 times a times b, which in this case is the x and the 5. So 2 times the x times the 5, all right? Plus your b squared, this if x was a and your 5 was b. So your second term squared, which would be my 5 squared. It's going to be an x squared. 2 times x times 5 is 10x, and then 5 squared is 25. Essentially, all you're doing is you're going to double your middle term to get the 10, and then you're going to square the last term. All right, so the more we do, you'll see this pattern. Say I gave you an x plus 3 squared. It would be x squared plus 2 times x times 3, or 6x plus 3 squared, which would be 9. If I gave you an x plus 10 squared, it would be x squared, the first term squared, plus 2 times the first term times the second term. So 2 times x times 10, that would be 20 x's, plus the last term squared. So 10 squared would be 100. Are we seeing the pattern? What if I gave you an x minus 2 squared? It would be x squared, notice they're all x squareds, plus 2 times x times negative 2. So because it was negative, this is going to be a negative 4x. Plus the negative 2 squared, and when I square a negative, that is still a positive 4. You'll notice the last number is always positive. The last number is always positive, but if your second term was negative, your middle term will be negative. So if I gave you an x minus, 6, it would be the first term squared, x squared, plus 2 times the first times the second term. So 2 times x times negative 6 would be negative 12x, plus the negative 6 squared, which would be a positive, always a positive, 36. Do we see the pattern? All right, let's hope so. So if we do, using that pattern, for a perfect square, what I would have here for the perfect square binomial, it's going to be just the x minus 3 squared would be the x squared plus 2 times the first term times the second term, which would give me a negative 6x, plus the negative 3 squared would be a positive 9. And then I would just drop down the rest of the equation. So I had a 2 out in front of all of that and a minus 5 at the end. All right, so this 2 would be distributed to everything inside the parentheses, everything I just used to square. So this would be a 2x squared. 2 times negative 6x is negative 12x, and 2 times 9 is 18, and I still have this minus 5 out there. All right, I'm almost there. I just want to combine our like terms at the end here. So I have a 2x squared, I have a minus 12x, and 18 take away 5 is 13. That is standard form. That is my ax squared plus bx plus c. right? Let's try that again. I believe this number was a 10. So first I want to pay attention to my exponents, right? Because we want to do PEMDAS. So my exponents come first to figure out what's in my parentheses here. So x minus 1 squared, if we use that pattern, it'll be the x squared plus 2 times x times negative 1. So that will give me a negative 2x. And then plus the negative 1 squared. Negative 1 squared is a positive 1. All right, then I'll just drop down the rest. So I had a negative 3 out in front of everything and a plus 10 at the end. The negative 3 will distribute to everything inside the parentheses. That'll be a negative 3x squared. Negative 3 times negative 2x is a positive 6x. Negative 3 times 1 is negative 3, and then I had that plus 10. So my final answer will be the negative 3x squared plus the 6x, and the negative 3 plus 10 gives me 7. Oh, I can, of course, drop down the f of x in the front. The f of x equals, and that is my standard form. Okay, not so hard. One more. All right, let's say I gave you a fraction, because we all love fractions. Say I gave you a 1/3, x minus 6 squared plus 4. And let's go ahead and put the star on here. Yes, your star will have a fraction, because we all love fractions. So say I have f of x equals 1/2 x minus 4 squared minus 3. That's your star. Okay, so I'm going to use my same pattern. And again, if you are not comfortable with the pattern, or if you, if you're not comfortable with it, you can always write it twice. You can always say x minus 6 times x minus 6 and FOIL that out. You'd have your x squared and minus 6x, and then a minus 6x and a 36. Which will give you x squared minus 12x plus 36, which is the same thing I would get if I use our pattern. So I have x squared minus 2 times x times negative 6, that's negative 12x, plus the negative 6 squared would be a positive 36. And then I'll drop down what I have in the front and the back, 1/3 and the plus 4. And again, you see how this is the same thing, so you can get the same thing by foiling as you would if you use the pattern. All right, so 1/3 x squared, 1/3 times negative 12, which is negative 12 divided by 3, that'll give you negative 4x. And 1/3 times 36, that's 36 divided by 3, which is just 12. And then you have the plus 4. And then I'll add my like terms at the end, so 1/3 x squared minus 4x. The 12 plus the 4 come together and give me 16. And then, of course, I can drop down the f of x in the front. And there you have it. I have converted from vertex form to standard form. Number 4 is your star.